Okay, so we are doing motion. Now, motion, in my opinion, I feel like is the one that messes y'all up the most. It's not hard to solve. It just gets a little confusing on how to set it up correctly. So I will tell you, if you ask me how to set it up, like, you'll have to draw a picture. The picture, when I say picture, I'm talking like arrows, y'all. Nothing fancy. Okay, so the equation we use to help us with motion is rate times time equals distance. So we know that we have r times t equals d. So r is your rate, which is just like your speed. Okay. T is your time in hours. And d is your distance. So if you see how far, we're talking distance, right? If you see how long, we're talking time. I mean, I guess if they say how fast or how slow or whatever, they could talk rate, but you don't really see that. Okay, any questions with those? Okay, so knowing that, we're going to read the problem. Now, on this, in this column, you're never going to plug in numbers, okay? Kind of like yesterday. Remember that farthest to the right column, we didn't plug anything in, we multiplied? Same concept. You're going to do rate times time to figure out what represents the distance. So don't ever fill anything in here. Yes? Okay, sometimes it does give you a distance. Like right here it says are about 200 miles. That's not going to go in our table. You'll see where it goes in just a second. So let's read it and then we'll talk about it. It says Chicago and Green Bay are about 200 miles apart. If a car leaves Chicago traveling towards Green Bay at 55 miles per hour, at the same time a truck leaves Green Bay bound for Chicago going 45 miles an hour, how long will it take for them to meet? Okay, so to reel all that in, we know that we have Chicago and we have Green Bay, right? And what do we know about that distance? It's 200 miles. So we know that this blue line represents 200 miles. Now, I will tell you, your pictures are always going to represent distance because can you draw time? No. And can you draw speed? No. Okay, so it's always going to represent distance. Okay, so knowing that, our first car left Chicago, so I'm going to label this C for Chicago. And how fast was the car that left Chicago driving? So that's our R, that's our rate. And then it says at the same time, so we know same time, that's important. Okay, as the truck left Green Bay, so this one's leaving Green Bay, how fast is that one going? 45 miles per hour. Okay, well, I don't know their time, but what do I know about time? It's the same. So if it tells me nothing about time, I know my first unknown is always x, but it does tell me they're the same time. So if this is x, this is also x. Yes? So what represents the Chicago car? Well, the Chicago car left Chicago and is driving towards Green Bay, right? So we multiply r times t, which is 55x. So this pink line is represented by 55x. Remember, our drawing is distance only. Then we had a car that left Green Bay headed towards Chicago, and what represents that is r times t, which is 45x. And in the end, we want to know where they meet right before they pass each other, right? Okay, so knowing that, how do you think you would set up this problem? Yeah, you're going to add them. If they left the destinations and met in the middle, or not necessarily the middle, one's driving faster than the other, but met somewhere in between, isn't their total miles going to be 200? Yeah, so this pink and green line together, so 55x plus 45x equals the dark blue line, which is 200. So the only part that's confusing is just setting it up. Once you set it up, y'all, it's not hard to solve. Is this a hard problem to solve? No. What do we do? combine. What's 55x plus 45x? And now what? Both sides by 100. And what does that equal? 2. Now, before I box 2 and say I'm done, what do I always need to go back and do? Read the question. And it says how long, which represents time. And if I go to the table, what represents time over here? For both of them? X. So X is my answer. What do I write? 2 what? Hours. Okay, here's my hypothetical question. What if it said, how far did the Chicago car drive before they met? Well, what represents my Chicago car's distance? 55x. What does x equal? 2. So what's 55 times 2? 110. So your answer would be 110 miles. Even though x equaled 2, your final answer can be different, right? So just make sure you're going back and actually reading the question. Yes? Okay, look at number 2. Okay, this one is super similar to number 1, so it's not super different. The other two are going to be a little different. Okay, so it says the 2 boats leave port, one heading east at 12 miles per hour and one heading in the opposite direction west at 10 miles per hour. How long will it take before the boats are 33 miles apart? So again, I don't fill in anything in this last box. And I know that they both started at port. And if you're like me, north, never eat sour worms. Some people say soggy waffles. That makes me want to throw up, so I don't. Okay, so the first boat, there's not really any way. I guess the boat that's going east. Okay, well, east is to the right. Is driving how fast? 12 miles per hour, so I know my rate. And what is my boat that's going west traveling? How fast? 10. Okay. Does it say anything about time? No. So we are going to assume the times are the same. Because if the times are different, I have to give you that information. So if it ever doesn't say anything about time, you're just assuming they're both x and that's what it is. Okay? So now what represents the distance of the east boat? 12x, because 12 times x is 12x. And what represents the distance of the west boat? Now, what is my question? Yeah, how long will it take before the boats are 33 miles apart? Why was that hard to say? I don't know. So I want to know when this boat and this boat are a total of 33 miles apart. So how do I set that one up? Yeah, same as the first one. I'm adding them together. So I get 10x plus 12x equals 33 because the pink and the green line together are the same length as the blue line in my picture. Okay, well, that equals, you're exactly right, that equals 22x equals 33. Now what? Divide both sides by 22. And what do I get? 1.5. Now, I know, well, first off, read the question. How long will it take before the boats? So how long is time? Time is represented by x. There's no tricky questions on this one. So I know that 1.5 is my answer. However, with time, I want you to turn it into hours and minutes if it's your final answer. Don't ever mess with anything before you have your answer, only after. Yes? So the first number always represents your hours. So I know I have 1 hour. And now this one's easy because 0.5 is how many minutes? Yeah, because it's a half, and half an hour is 30 minutes. Don't tell me 5 minutes. Don't tell me 50 minutes. I've seen that today. If you're not sure, do y'all remember what you do? You take just the decimal and multiply it by 60. So 0.5 times 60 is 30 minutes. Does that make sense? So if you ever get like a weird decimal like 0.15, you would just multiply by 60 and it's 9 minutes. Does that make sense? Okay. Any questions on number 1 or 2? Okay, so now we're going to kind of change things up a little bit. Look at number 3. It says a car leaves Houston heading east at 50 miles per hour 1 hour later, a second car leaves Houston heading east at 65 miles per hour. How long will it take the second car to overtake the first car? Why will the second car end up passing the first car? Because it's going faster. Even though he left later, he's going faster. So if they're going far enough, eventually he will pass him, right? So I know that I have the first car and the second car. I know that they both started in Houston and they're both heading east. Do I know where they're going? No. So my first car is driving how fast? 50 miles per hour. Okay. And my second car, now before we draw the line for my second car, to overtake, don't they have to be the same first? And then as soon as they're the same, the faster car will pass, right? So we're looking for where their distance is exactly the same. So we want to know when that second car gets to the same distance, because as soon as they're the same, he will pass them. Does that make sense? Okay. So how fast was the second car driving? 65. Okay. Now, do we know how long it took either car? What do we know about time?
1 hour later.
The second car left 1 hour later. So I don't know the time, so I'm going to put an X. Now, which car had more time? The first car. How much more time? 1 hour, so plus 1. Now, technically, you could have asked yourself which car had less time, and you could have had X and X minus 1. You'll get the same answer as long as this one has 1 less. Well, if this has plus 1, isn't that 1 less than just X? Yes, so no matter what, as long as that second car had 1 less hour, you'll get the answer. Okay? So now I need to figure out what represents both of their distance. Well, 50 times X is 50X. 50 times 1 is 50. So my pink line is represented by 50X plus 50. And what about the distance for my blue line? Green line. So this one's represented by 65X. How do you think, looking at the picture, we're going to solve this? Huh? Not combine. No. Yeah, they're equal to each other because we want to know when their distance is equal, right? Time, we're not thinking about time anymore. When it comes to solving, we're only thinking about distance, okay? We use the time to figure out what represents the distance, but we want to know when they're the same. Well, isn't the pink line and the green line at the same? Aren't they equal? So when it's equal, when your arrows are equal, you just set them equal to each other. How would I solve this? Minus 50X. And that leaves me with 50 equals 15X. Now what? Both sides by what? And I get X equals what? 3.3 repeating, right? Which is important because if you round, you're going to get a different answer. Okay, now 3.3 repeating we can represent, so that's not a big deal. It says, how long will it take? So we're looking for time. Does X represent the time of my second car? Yes, so I know that this is my answer. But if you ever ask me a question and I'm like, oh, well, in 3.3 repeating hours, are y'all going to look at me like I'm crazy? Yes, because that's not the proper way to answer a time question. You want hours and minutes. So again, we know that this is our hours. So it's 3 hours. And now, I know that nobody wants to sit here forever to type a billion threes in. Your calculator, if you just go all the way across the screen, see how I went all the way and it's an arrow now? Takes 2 seconds. That's considered 3 repeating. Your calculator will treat it the same. So then you'll just do times 60 minutes. And what does it equal? Because if you round and you do times 60, is it the same answer? No. It's close, but it's not the same. Does that make sense? Okay. Last one. This one again is a little different. It says Maria and Mike are traveling to a business conference. So I know that both of them are going to this business conference. says the trip takes 2 hours for Maria. So Maria, what do I know about her? Her time is 2. All the other ones haven't given me time. This one gave me time. And then for Mike, how long did it take? 2.5 hours. Because why? He lives further, right? And then it says Mike travels 5 miles per hour faster than Maria. Well, do we know how fast Maria's driving? No. So that's my first unknown. What represents Mike's rate? X plus 5. Because he's going 5 miles per hour faster. What if it said 5 miles per hour slower? Exactly right. Okay. So now to draw our picture. We know that Mike had to travel further than Maria. So Maria's line is going to be shorter. Right? But to set up this problem, I need the lines to be the same. Do I know how much this gap is? It's 40. Why is it 40? Yeah, he's 40 miles further away. So this is represented by 40. So I know that Maria's distance is represented by x times 2, which is 2x. So this little pink piece is 2x. And I know that Mike's distance, I have to distribute backwards, which is fine. 2.5 times x is 2.5x. And then 2.5 times 5 is what? So this is 2.5x plus 12.5. How do you think we find the answer? Well, which line's longer? My green one, right? The bottom one. Or not longer, but it's equal. Like there's nothing there to make it. Okay, it's one line. So I know that this line is equal to what? 2x plus
40.
Yeah, not 2 dot. Goodness gracious. This pink line needs the blue line to be equal to Mike's line, right? Because if I don't include the blue place, are the pink line and the green line equal? No, but if I add that 40 in there, now are they equal? Yes, so 2x plus 40. How do I solve that? Minus 2x on both sides. If you move something else, that's okay. You'll have a negative, but you'll divide it out in a minute. So this gives me 0.5x plus 12.5 equals 40. Now what? So minus 12.5. And I get 0.5x equals what? 27.5. Now what? Divide both sides by 0.5. And what does that give me? 55. Now, am I done? Do I just box it and call it a day? What do I need to do? Read what it's looking for. It says find their average rates. Well, I found one of them. Whose did I find? Maria's. I know that Maria is going 55 miles per hour. What represents Mike's rate? X plus 5, right? And x is 55, so what's 55 plus 5? So there's both of their rates. So again, be careful, make sure you're reading the question, because what if it said, how far did Maria drive? Well, what represents Maria's distance? 2x, and what's 2 times 55? We're just like, yeah, 110 miles. Okay, any questions with this? Okay, there are 2 things I want to talk about on the practice. Simple things, but they can be a little confusing. So if you look at number 1, one thing I want to say, so let's read it and then I'll tell you. It says, in the morning, Sammy drove to a business appointment at 50 miles per hour. His average speed on the return trip in the afternoon was 40 miles per hour. The return trip took 1/4 of an hour longer because of heavy traffic. How far did he travel? Well, we're only thinking about time right now. Y'all can do the rates. They're given to you. I don't know how long it took his trip there, right? So my first unknown is x. What does it say about the time in the return trip? It's 1/4 of an hour longer. Do not turn this to minutes because we're given miles per hour. And if you multiply miles per hour times minutes, does that go together? No. So when you plug it in, you're going to do x plus, you can keep it as a fraction because your calculator helps you. Or what's 1/4 as a decimal? Yeah, 0.25. So leave it in hours. The only time you're going to change it to minutes, y'all, is if it's your final answer after you've solved everything. Does that make sense? So be careful with that. Okay, the next one says, on vacation, Eve averaged 50 miles per hour traveling from Denver to Minneapolis. Returning by a different route that covered the same number of miles, she averaged 55 miles per hour. What is the distance between the two cities if her total time was 32 hours? Well, does it tell us anything about how it's split? No, and she's not traveling the same speed, so we can't just cut it in half. So remember, when you know the total, just like yesterday, what is our first unknown always? And then what do you use to find the remainder? Not plus. Well, what's my total?
X minus
Flip it. 32 minus x. Your total minus your first amount. Because wouldn't that find the remainder? If this is 10, and I know it took 32 hours, 32 minus 10 would be 22. So it would have been 22 hours. So you subtract with your total minus your first. Any questions with that? Now this one, when you solve for x, you are going to get a decimal. And it's not a pretty decimal like the other ones were. But does it ask me for how long? Or does it say what is the distance? So you're going to have to round it to plug it back in to find distance. Your answer might be a little different than mine because what if I rounded different? Okay? So just know that my answer has this squiggly line. Do y'all know what this means? Yeah, about or approximately. So if your answer is close to mine, we'll say within like 10 plus or minus miles, then your answer is correct. Does that make sense? Now, if you have something like 100 miles off, that's not close, okay? Then you did a mistake. But for the most part, everybody will be within a couple miles to my answer or get the same answer as me. Does that make sense? So just know it all depends on how you rounded to get the exact same answer here. Okay? Any questions? Okay, so this is what you're working on.